Hello and welcome back to this third installment of the Python for Bankers series. This video we're going to explore a hugely important concept in perhaps the entirety of Python programming, and we are of course talking about object-oriented programming. Why is this important? Well, because in Python everything is an object. So we've seen the remainder of the series just how much of a role objects play in this programming language called Python, but for now let's dive in. Let's create some objects representing accounts, bank accounts, and understand what this entity known as the object is. Okay, so because everything is an object, every entity has some metadata called attributes and associated functionalities called methods. Attributes, methods. These attributes and methods are accessed using the dot syntax that you see very shortly. Now you don't have to write any of the code here because they are all provided to you in a GitHub repository, and by the end of the video, as long as you've gained an understanding of objects and methods and attributes, then it has served its purpose. Let's get started. Every object created in Python is generated from a class. You can imagine a class as just a blueprint for creating an object. And I'm using Visual Studio Code. This is spelled Visual Studio Code. So if you want to follow along this part of the exercise, you can actually go ahead and download Visual Studio Code, or you can use any of your favorite code editors. There's a bunch of them. You can use Atom, you can use Sublime. It's up to you really. But I'm gonna use Visual Studio Code. I've been using Visual Studio Code for the past maybe 5-6 years and I love it. So I'm gonna stick to it. It's up to you really what you want to use. Okay. Now how do we get started with classes? Well, we use the class keyword in Python. So there's a class keyword. We say the class and we put a capital case name, and here we're gonna call our class account, so representing bank accounts. If you ever been to a bank, open a bank account, your bank account contains a lot of metadata. It contains things like what is the account balance, when is it created. It contains things like whether you have enough sufficient balance or not, account type, whether it's a savings account, checking account, current account, and so on and so forth. There's a lot of information, a lot of metadata, and those are going to be either attributes or they're going to be methods, and we're going to implement them. So here is how we implement our class. And for now, I'm not going to do anything. I'm just going to use the pass keyword. So this is another Python keyword that says just move along. There's nothing happening in here. Just move along. Okay, so pass. So there's 2 lines of code. And then what we're going to do is we're going to create an instance of that. So we're going to say this is my account. So I'm going to say my account. And I'm going to just put account. And that's how we instantiate a class. So this is the recipe, this is the blueprint, this is the formula, and this is creating a instance of this formula. Does that make sense? So this is the object blueprint. We're creating an object based on this blueprint. So what is in the blueprint? It depends on what you want to implement into the blueprint, and we're going to be doing that. But for now, once you have this, I want you to just save the code. Just click on File, Save As, save it anywhere you want. I'm saving it under my Python for Bankers because all of them will then be pushed to GitHub and you can download the code and you can work along that. And then what we're gonna do now is we're gonna hop in here. I want you to make sure that when you save it, you can name it anything you want as long as you end it with a .py extension. .py tells your computer that this is a Python script and that it should be executed using Python, the program. So down here, we can go ahead and say Python, and we can say demo.py because that's what we name our file. If you name it demo01, you want to change this to Python space demo01. Okay, so once you have that, you press enter. And how you got this up, you can either open up the terminal, or you can use, if you're using Visual Studio Code, you can do the terminal and then you can say show terminal. Okay, so if you use another code editor, you need to find where that setting is, but most code editor or most IDE, most development environment will provide you with this embedded or integrated terminal. So now that we have an account, what do we do with it? So let's go ahead and actually create, let's start off by removing the pass. Let's implement some functionalities. So almost the first thing you do where every time you create a class is you create something called the init. This is called dunder. Dunder stands for double underscore. So double underscore init, and you implement your initializing method in here. So init basically says every time this is called, every time the account is created, every time an instance of the account is created, perform something in here. So I can say perform something like print I can say created something, created an account. I can do that, right? I can do all kind of things in here, but every time it's created, then this print statement is going to execute and you're going to be able to see something. So if I hop down here, well, of course we have to pass in the self, because every time you call init, it actually takes the instance as the first parameter. So now if you run it, it says created an account. So passing in self is a way of saying that, okay, so every time you create this, by default, it would already pass in the instance itself as the first argument, as the first parameter. So in this case here, self is just gonna be whatever it is that is created, whatever instance that is used to create this object. Okay, so once we have that, we have the print statement. Now we don't need that, we can just remove it, but we're gonna keep it there for now. And I want a few things in my account. I want a few attributes in my account. So the first thing I want an account number. So I'm gonna say that when somebody creates an account, I want them to pass in an account number. So this is gonna look like that, account number. I'm also gonna create an account with some account balance. So for example, if you go to a bank and you want to create a new account, create a new bank account, you need to put in some money, start off with an initial balance, and so that's gonna be called account balance. So account balance, it's gonna be like that. So account number, account balance. Then how do we tweak this init? We're gonna actually put account number and account balance because they will receive these two parameters as well. They receive these two as an argument. So what happened here is that every time you create you call the account object constructor, and within the constructor you would have to pass in both the account number and the account balance. And this account number and this account balance in turn is going to be passed in here and then be used within the constructor function itself. So I can actually say something like 100, or let's say this is the account number. I'm going to say 555-555-005. Okay, and for the account balance, I'm going to start off with 100 Sing dollar. Okay, so this will then be passed on to account number, and 100 will be the account balance that we pass in here. So what do we do now is to bind them. We bind them to the object itself. So we're gonna say self account number. You can obviously name it anything you want, but as a convention, I like to name it the same thing here. So later on, this allows me to do something like print my account dot account number. If I name it differently, if I say this is account number, then I will then change this like that. Okay, it still works. This is no problem at all. It's just that as a convention, I like to stay to the same thing. I like, if I put ACT_NO, I like to put ACT_NO on the left hand side as well. But we keep it there, and I'll change that later on just to demonstrate that this whole thing still works. Okay, and then I also have to bind account balance. So I need to do something with the account balance because you pass it into the constructor function. You need to do something with it. So what am I gonna do? I'm actually gonna say account balance. That would be ACT balance. Okay, so I want you to just pause the video a little bit and try to understand what is happening here. Okay, so let me explain that again. So init is called every time you instantiate or you create a new instance of. Okay, so every time I create this, I can create. Let me do another one here, and I say this is your account. Now every time that the account object constructor is being called, init is going to be executed, and I will see this printed, and then I will see that the binding is going to happen. So I can then say something like here and copy that, paste it down here, and I can change this to your account. And let me just change things a little bit here. So instead of 100, I'm going to have 100 and 300 here. Right? I can actually change this to account balance as well. And then what's going to happen is that it's going to say, now this object will now contain a new attribute called account number. Now what is that number is going to be? Well, that's depend on what you pass into the ACT_NO. What do we pass? We pass in this one. Okay. As well, it's also going to have a new attribute called account_balance. Now account_balance, what is that going to have? That depends on what you pass into the ACT_balance. If you pass 300, then that's 300 is going to be assigned into this. So obviously the little bit of prerequisite is that you need to understand a little bit about how Python works in general. You need to understand about integer and strings and data types and object types and stuff. But once you understand that, this shouldn't be too much of a step up from your basic understanding of Python. Okay, so I'm gonna just save this file now, just hit Ctrl S or Command S, and then go all the way down to my terminal and run my code again. And what do I see? It says created an account. So this line number 10, first execute. Let me zoom in a little bit so you can see better. Okay, so the first line executed and I see created an account. And then what do I see next? Well, I see my account number. So my account number is right here, self.account number. So it says this instance will now have this attribute called account underscore number. Now, where did the number come from? That depends on what you pass into it when you construct it. Okay, so I mentioned earlier that as a convention, I like to make them the same. So I'm gonna just replace that. And if I run my script right now, I'm gonna get an error. Can you tell me where the error is? Can you tell me why am I gonna get an error? Well, of course, I'm going to get an error because now this account underscore number doesn't exist as an attribute anymore. Now it should be ACT underscore NO. So I'm going to copy that, replace it here, and I'm going to do the same for account balance. So it's going to be ACT underscore balance. Okay, so what it's going to say is that every time you create an account instance, you pass in two items, parameter 1, parameter 2. The first parameter is bind to ACT underscore NO, and the second parameter, ACT underscore balance, that value is going to be passed along to ACT underscore balance. Okay, now let's run all of this and make sure that it still works. Sure enough, it all still works. So this is really the essentials, the bare bone of that. Now let's make things a little bit more interesting. Let's actually, instead of just having account number and account balance, we don't need this print statement anymore. So I'm going to just remove that. And just to make things a little bit more interesting, let's do a few more things. Let's actually also have a account type. So if somebody comes to a bank and asks for a new account, this person may want a long-term savings account, may want a current account, it may want a I don't know, investment account. So we're gonna have something called the account type as well. So we're gonna say self type. So this will allow our account to contain the attribute called type. So we need some value in here. What value do we want? Well, it depends on what was passed on when we first create that. So I'm going to have type in here, pass that in. So now when we create a new account, we need to pass in three things. Self is always passed in automatically without you doing anything, all right? So self is always going to be the first parameter. You don't have to pass in anything. You need to pass in account number, account balance, and the type. So let's call this a current account or savings account, and let's call this a current account. Just like that. And let's also have another one. Let's put created date. Okay, so every time somebody creates an account, we want to actually have it on our records, on our bank records, the date time of when this account was created. Now there are multiple ways you can implement that, but I thought that maybe one thing we can do is to have it automatically assume the date of right now, the present date time. Okay, how do we do that, I wonder? Now how we do that, let's go ahead and actually not implement. Let's just put a 0 right now, and let's go up here and do something called import, or rather from datetime, import datetime. So when you download Python, when you install Python, Python comes with a lot of built-in utilities, a lot of built-in functionalities. One of it is the datetime, and datetime that's built into Python core library. So when you install Python, you don't have to additionally install things like datetime. It comes with it. It comes with it. Okay, so when you install Python, it comes with datetime and along with all kind of utilities that you may be using in the construction of your script. So among them is datetime, and that allows us to do things like datetime.now, and that will actually just take the current time and pass it into the created date. So this is cool because I don't have to require that from the constructor. So when you create an account, you don't have to pass in the current time, rather it would just create that using the current present date time. Okay, so and to prove that this all still works, I'm gonna just remove these two lines of code, and I'm gonna just go ahead and say print, and I'm gonna say my account, and what am I gonna do? I'm gonna say created date. Okay, so if this works, I would see account number, which is this number right here, and I will be able to see created date if this all works as planned. Okay, so let me save the script right now real quick and go back down here, call the script again, and what do we have? We have this. So that's really cool because that's the account number, but we also have the date time, the created date. Okay, so this is clearly working because now we have the created date, and we have datetime.now taking exactly the datetime right now on the computer, and it passed it along when you created that, when the init constructor is first called. Okay, so this is a class, this is an instance of the class. Now, what's really cool is that we can actually also keep track of the total number of accounts that are created under our system in this new system that we just created. So I'm going to go up here and I'm going to create a attribute on the class. This is a class attribute, and we're going to call it total accounts, and we're going to start off with 0. So we're going to say the total number of accounts on our system, that would be 0, but every time that the init function is called, I want to add 1 value to that. So initially, when I call this value, just to show it to you, I'm going to say print, and I'm going to say account.total accounts. Okay, so what is this doing? Well, this is going to say, give me the class attribute of account, give me the class attribute total accounts of account. And what am I expecting here? I'm expecting 0. But every time a new account is created on the system, I want to add 1 to this value. I want to increment this value by 1. So every time the init function is called, I want to do something like account.total accounts plus equal 1. This is the same as taking this and writing it here and plus 1, except this is a little bit more verbose, and I like to just put a plus 1 and just in place do the addition in place. So every time the init function is constructed, add total, go to access total accounts and add that by a single increment. So if I create my account, this is my account, and then I create my second account, this is your account, and I print account balance, and at the very end, I'm going to say print, and what am I going to print? I'm going to print account.total accounts. Can you guess what value do we expect here? Take a second, pause the video, and try and think about what just happened, reason about that, and try to guess what would be a reasonable guess here. What do you think the total accounts would be? Well, if you guess 2, let's see if you're right. So we're going to save the file, come back down here, Python, and bam, we see 2. So what happened here is that the first time it's incremented, it's when we initialize this called my account. So account.total accounts is going to plus equal 1, it's going to say 0, and that's going to add 1 to these total accounts. So the second time it was called is in this line, account. We create another account, we add $300 into our account balance, and we have a savings current account, and now total accounts is 2. So this is a way for you to keep track of how many accounts were created in this, how many account object was created, because we have a total accounts, and every time init is created, is called, this line of code gets executed. Okay, so far so good. Everything is making sense still. Hopefully everything is making sense, but this thing can go a lot more than just creating a simple class and then just creating instance of the class. Because what this allows us to do, and this is really where the power of object-oriented programming comes in, is we can now create things based on this blueprint, meaning we can create a sub-blueprint based on properties of this blueprint, okay? And this is actually more formally known as inheritance. So what we can do is we can inherit from account and create another kind of, let's say a special account. So one example I can think of is the multi-currency account that DBS offer. So if you ever have a DBS bank account, you can actually start a multi-currency account, and that allows you to create an account that holds, let's say, USD and Sing dollar and Indonesia rupiah and all the other currencies, any currencies that is supported on the multi-currency account that DBS has to offer. Okay, so let's just waste no time and let's just get started creating a multi-currency account. So I'm gonna go ahead and say class, because that's how we use the class keyword to create a class, and I'm gonna say multi-currency account, and I'm gonna try to implement my functionalities in here. But you know what? Instead of actually trying to implement and copy and paste and do all of this work here, what I can actually do instead is to just maybe inherit from it. So I said, well, I'm just going to inherit from all of these things that you implement, because at some point you're going to add more functions to account. So all the accounts would have access to all of the methods and all of the properties, and this one should benefit from it because it can take that as a parent class. So the way we do that is we just put a bracket and then we put in the name of the class. And just to show you that this works, I'm gonna remove all of this right now. Just gonna remove all of this right now. And I'm gonna create a multi-currency account. So I'm gonna say an multi-currency account, MCA. And I'm gonna do that by doing multi-currency account, and I'm gonna pass in values as well. I'm gonna say maybe 100, and I'm maybe gonna put let's say put a number that makes sense here, 6, and I'm gonna start with $500, and this is gonna call a, let's say, investment account. Okay, so when I implement this, when I implement multi-currency account, I inherit from account. And so it would have all of this nice stuff from its parent class, which is account, but I do need to initialize it because I haven't actually specified the initialize. So what do I do in here? Well, I can just go ahead and say define, again, dunder, which is underscore init, and now instead of doing all of those things, I can just slowly just inherit, just use super as a keyword. So what super does is that it says call the parent init. So super says go to the parent class, which is this class. This is the parent class, and call the init of the parent class, which is here, and pass in all these 3 items in here. So what this is doing, again, what is super again? Now super says go to the parent class. So the parent class is specified in account, so it's going to go into account, right? And it says call the init method of the parent class. So this is the init method of the parent class. Remember, what does the init method takes? It takes account number, account balance, and type. What about self? Self is already inherited. It's automatic. Okay, so you don't have to pass anything. So you just need to pass in the account number, account balance, and type. Why do you need them? Because without them, you cannot create their attributes on your object. So we have the account number, account balance, and type. So we do require to pass in the 3 items in here. So what this will allow us to do, and you see very quickly, is we can now say something like print MCA, and I'm gonna say created date. Now notice that created date wasn't really implemented in the multi-currency account blueprint, but it was because we inherit from account, we should still expect the functionality. So let's go ahead, save all of this, go ahead and run the code now, and what do we see? It says 0. So initially there is no total accounts, but because we created account number 1 and account number 2, we expect to see 2. So print created date, so it says 0. This is the first print statement, it returns in 0. The second print statement returns in the created date, and the final print statement, total accounts, they count as 2. There's the account and there's the multi-currency account, that's 2. So total accounts from 0, it adds up to 2. So what does it tell you? It tells you that total accounts is also inherited into this one, and so when you create a subclass of it, when you inherit from that class and you initialize it, it calls the parent's initializer, and then within it is still added 1 anyway. So if it doesn't, if it haven't inherited the parent init method, then it wouldn't have called this, and you wouldn't have expected 2. You would have expected maybe 1. Okay, so now that you see this returns 2, which confirms that the child class actually inherit correctly, and the init is still called on that. So super is just a way of saying access the parent class. Okay, so this is where you can then go ahead and create even more account types, and you can maybe inherit from that. You can inherit multiple class. You can say this one, and you can inherit another one, maybe called the I don't know, you can maybe have like, here doesn't really make sense, but I could have like a customer if you want to. It doesn't make sense here, but you can inherit as many classes as you want. In this case, let's just keep it simple to just demonstrate the idea. Okay, what if multi-currency account also want to accept more parameters than the 3? You want to accept more arguments, so what can you do here? Well, you can also do that. The way we do that is to just pass in more items. We said, let's say we want to pass in a list of currencies, then we can pass in currencies here, and then what we can do is we can just bind the currencies to currencies. So we say currencies equals to currencies. Of course, you can name this anything you want, but here I'm saying that if you take the MCA and you find currencies, then this attribute should exist because you created that here in the initialize method, and in the initialize method, you bind that to the value that you pass in here. So you do need to pass in a list of all the values. So I'm gonna say SGD IDR. maybe USD. Okay, and if I save that and I go down to my terminal and I run that code, I should expect to see SGD IDR USD. And notice that this currencies list, this only makes sense for a multi-currency account, but it doesn't make sense for a basic account, because the basic account, it would always be, let's say, in the base currency of Sing dollar. All right, so in this case here, or IDR, wherever you're from. Now the whole idea is that you can inherit from a parent class, and whatever it is that is not implemented in the parent class, you can add to it. And here we add to it, we add currencies attribute. We said take that value from currencies and bind that to the self.currencies, and we can do that. Where in the parent class itself, we don't actually have that, right? But everything else that is not currencies, everything else we just sort of delegate that back to the parent. And how we do that is called super, and super actually says take that and pass it back to the parent, and this is the parent. It says, okay, in the parent itself, find the init, which is here, and perform all this binding right there. And that's it. That is how you now created that is the account, and that's the multi-currency account. So take a second, pause the video a little bit, and try to understand that. Once you get familiar with it, we move on to the next video, and I'm going to show you how we can add to this idea, and that would be OOP part 2. So see you.